Just a minute. Hey everyone, g'day. So this is the Plasma development live stream, and I'm going to continue work on the garbage collector for the Plasma programming language. If you'd like to join the chat, you could either use Twitch to chat, or if you don't have a Twitch account, the Plasma IRC channel is also visible in the stream, and so I'll be able to read questions from it and respond to them, and it will be visible in the recording, so when it's played back, it'll make sense. So what I want to do, I'm just going to show where we left off. So I've done some other work on implementing tail calls, and that's now been merged into the master branch. And then I've merged the master branch into this GC dev branch, which is my own private branch. And that follows from the GC branch, where we were working on the garbage collector here. So we've done the work on the garbage collector. What happened was that we found it wasn't finding any garbage, because without tail recursion and with the poor use of the stack in the code generator, there was nothing actually ever became dead, because there was always a pointer from the stack to anything that we'd ever used. So by implementing tail calls, now we're able to, because stack frames are never kept now, when they're finished, they're finished. And sorry, I said not ever. It was very rare that something disappeared from the stack, so you had to use a convoluted style. I can show that in a moment. But now with tail calls, it's easier for something to stop having a pointer to it from the stack, and therefore we're able to collect memory. The remaining problem, and there's two reasons why it's not gone onto the master branch yet. It needs a lot more asserts and other checks to make sure that it is actually working properly, and it doesn't handle fragmentation very well at all. Once a cell is allocated to a particular size, then that's the size it's always going to be. And a larger allocation, even though there were two cells right next to each other, couldn't be satisfied. Now that's fine in some collectors, but in this test I was actually using a really... there's no reason with the particular heap layout that I've chosen, at least for the first version, because it's like I've said in the previous streams, it's the simplest garbage collector I could possibly create. And we'll improve it later. So it will be a better collector in later versions of the language. That's just not the priority right now. Yeah, so being a very simple collector, it has a fairly simple heap layout, and that heap layout should be able to merge cells that are next to each other and free. So it's a matter of implementing that. So yeah, so those two things in that order is what we'll be working on tonight. So and the stashed changes I have there, that's some other work that I had been doing to try and merge cells. So I'll share that when we're ready to see it. So I have coffee. I have no music. I'm not sure what the rules are about having copyrighted music in a stream. And that way you can play your own music. Or have it on in the background in whatever way you like. You do not need to be burdened with my tastes. Anyway. So we want to add more assertions. There was another thing I was thinking of doing, but now that I'm here and thinking of it, I've forgotten. Oh yeah, I want to fix up that test case. So don't need that test case or that one. That's a previous session that I was working on. Okay. So we want to look up the allocate lots test case. Part 2 is currently commented out. Part 1 does a fancy trick. So allocate lots 1, we look at that function here. Runs a loop because it has a recursive call. Plasma doesn't support loops yet, but it will. So it runs a loop, calls itself, but within each iteration it calls allocate lots 2, which is also a loop. That way, when this loop finishes and we return to the outer loop, those stack frames, by virtue of the return to this call site here that the cursor is on, those stack frames will be unwound from the stack, and anything that they were pointing to in the heap can be freed. So that's the fancy trick that we had to do to make heap allocation work. So now what we can do, we should be able to put a larger number there, allocate lots 1, remove allocate lots 2, and this should still work and be able to reclaim memory. Yep, that looks like it works. Yeah, and the rest of the test suite still works. I just wanted to check that it worked after I recompiled the runtime there. So simplify test links to tail recursion. Now that tail recursion is implemented, the workaround in this test can be removed. I think that's all it needs. Okay, tests valid. Allocate lots B. Good. Is the video frozen? No? It's just, it hasn't updated it from what I can see on the Twitch dashboard. Oh. I'm gonna leave it because it's probably fine. I just don't know for sure. Yeah. If I reload the dashboard only, maybe that will help. It gives me a little bit more certainty that I'm just not talking to myself. Anyway. Yeah, it seems fine. So, the other thing I'd like to test in that test case is, I know that if I uncomment part 2 and leave part 1 there, as it is, this should fail due to the fragmentation problem. It runs out of memory. So even though plenty of cells have been swept, 70, it still can't allocate memory due to fragmentation. If I remove test 1, then because test 1 uses smaller cells, it should not be a problem. That should hopefully work. No, it's still out of memory. That's interesting. Oh, it is genuinely running out of memory. Look at that. So, 0 cells swept means that there are literally 0 free cells anymore. So I'm going to bump up the heap size for this test. See, we had artificially reduced the heap size. Let's try that. Yep. That's working. It's just that the expected output saved in the tests directory is out of sync. So it traverses the tree in the correct order and prints all the items. And it needed to do collection. Actually, let's look at that again. Markings. Yep. Yeah, so this test fits within 8 kilobytes of memory, but not 4. So there are, yeah. So that's cool. So we do have some working things. Now, because of the fragmentation, now that I've got part 2 working, we'll leave part 1 there. Yep, just as that runs out of memory, just as before. Interesting that the increased that the increased heap size didn't help there. It didn't seem to change anything. Let's just double check. Yeah, interesting that the sweeping numbers were different. So here we're fitting 341 cells on the heap, but if I set 4 kilobytes and then 8 kilobytes here, we should see that last one change and fit more on the heap. So what I should see here is that it's 171 cells on the heap, blah 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 blah, all happy, until this point, where just before running out of memory, we should have increased the heap size before running part 2. Let's double check. So there's something not quite right. I would add a debugging printf into the source for the test, but because I'm printing those diagnostic messages to standard out, and the regular output the diagnostic ones to standard error, and the regular ones to standard out, they can actually interleave. So to make sure that I get the ordering correctly, I'm actually going to print it from the garbage collector itself. Set heap size. We're going to printf new heap size. I don't know if that may not be the correct format parameter. I mean, on all platforms it's going to work now, but I don't know if that's correct on 32 bits. Yeah, so we set a new heap size and therefore should get a different figure here when we're done sweeping. So why does the new heap size not take effect? Heap, set to heap size, new size. How far do we sweep? Well, actually, I think this is the problem in the allocation code. Because sweeping ends when the next cell has no set size, or has a size of 0, which happens if it's never ever been allocated before. But I'm willing to bet what's going on is in the allocation code well, actually, in try allocate, can't find an allocation. If best is not null, yeah, that's fine. There's a bug. Yeah, because this returns a void pointer. Heap is wilderness pointer. Yeah. Okay, I wonder what's going on. Oh wow, there's another problem here as well. Okay, well there's one problem. But it's now, the other problem here is that even if we fail, we've still updated the wilderness pointer, which means we've changed the state of the heap. This is not okay. So what we actually want to do is say void pointer. Is wilderness pointer a double pointer? Let's see. No, it's a single pointer. Void wilderness pointer. New pointer. Remember that the wilderness in a garbage collector is the stuff we've never touched before. So it might be memory that the operating system has given us, but that we've never ever touched. The operating system might not have even given us that yet, because the first time we touch it, we might get the page fault that causes it to be allocated. So, new wilderness pointer is the wilderness pointer plus size in words multiplied by the machine word size. So new wilderness pointer, base address compare with that, cell size is size in words, and at this point we've committed to allocating it. So now we can say heap wilderness pointer is new wilderness pointer, and do the other things we need to do to set up the heap cell, the allocation. That may fix our bug. Interesting. I think I might know. No? So we have this assertion during sweeping that I think is indicating that we're going beyond the end of the heap. So why would it think that we're going beyond the end of the heap? Maybe not. I mean, the while loop should keep us in check. You know, it's going to help. Let's add debugging symbols. I feel like every live stream, probably every coding session, but I only notice it because of live stream. We come and we enable debugging. It's happening a lot. That's not a bad thing, it's just a thing. Rebuild everything. Lots easy. Up. That's a funny looking address. Heap base address. No, it's in the correct. Well. Is it bigger? Yes. Heap size is 4096. Yeah. I mean, that's within range, isn't it? What have I've already forgotten what I've changed that could possibly do this. I changed... That doesn't make sense. Rather than updating the wilderness pointer, we compare the new under the base address plus the heap size. How? Unless it was relying on the buggy behavior, or there's something funky with the pointer arithmetic. Gonna double check on the pointer arithmetic first. So base address is a basic void point. Heap size is size t. Wilderness is void pointer. So it should be that when we add to it, we're just talking in bytes, and that's what that's measured in. Set heap size is measured in bytes. Yeah. So cell is wilderness pointer plus the machine size. No, I don't see it to be pointer arithmetic. So it's got to be that it was relying on the bad behavior. Cell size. So let's take a look at the sweeping code. Here. While base address plus heap size should be okay. Also is less than those things. If it's not less than those things, okay, now that we've got, what's happening is that this assertion has become more strict because the wilderness pointer is now valid, whereas it had a bogus value in it earlier, pointing past the end of the heap. So what we can do, what is a totally reasonable thing to do, is to make this the wilderness pointer. So don't bother scanning anything in the heap past the wilderness pointer. I don't know if that contributed to our bug, but we'll find out. Yeah, so there's a lot of me muttering, this is impossible, oh, that's how it's possible. Debugging, ladies and gentlemen. What am I doing? I'm not concentrating on what I'm doing, that's why. Make that test. That looks better. So what we get here, yep, new heap size, and now it sweeps more. So I wonder why this change fixed that bug. It's sweeping more. Oh yeah, because we... No? Because allocation, bump pointer allocation is now going to succeed more because we no longer have a bad wilderness pointer. That's why. And with an invalid wilderness pointer, even if it was in the heap, it wouldn't have been detected by the sweeping code because of one of the this exit condition here of this loop. That makes sense. So we've fixed a bug. This is not what we came here to do. Oh, not that I'm complaining. It's just interesting that, well, we said we'd do something else and instead we explored a little bit and found new bugs to fix. So that, I'll make them part of the same change, not that one. Do that one in a moment. Fix this bug by setting will succeed. I can never spell succeed. I can spell it less when I know people are watching. There we go. If you've just joined the stream, you're welcome to join the chat in the IRC channel. That's hash plasma laying on the Freenode network. There's information on the Plasma website, which is plasmalaying.org. But I'm also happy to take questions or anything from the Twitch chat. So, next problem. So I suspected I was right to think that that would run out of memory. Now, I just want to double check my suspicions that running part 1 after running part 2 will not run out of memory in the same way. Yep. I thought so, and that, yeah, because it's a fragmentation issue, and part 1 uses smaller allocations of memory. Seems better to actually write the power of 2 number instead of lazily multiplying. Doesn't change anything, but you know, it might show that I actually know it. I'm just going to put in an eye drop, so I'll be with you in a moment. I'm back, and now we'll look at adding more assertions and more defensive programming into the collector. So basically hardening it. So I checked out initialization's fine, freeing things is fine. That's fine. Now, when we find a new cell, we assert that it's not yet allocated. We've already read the size, so that already makes sense. Let's assert here, because when we read the size of the cell, that the cell size cell is not 0. That would be weird. So we forbid it. Did I not save that? Better. There's nothing else to check there. Here, because we're allocating a new cell, we're going to assert that it is 0. Double check that one. Yes, I did use a pointer. Yep, cool. That should still work fine. Allocate lot still fails, but it will. When we're done, we can actually delete part 1 of it. Well, I could do that anyway. I could not bother writing the cell merging code. It's rarely going to be a problem in practice. I mean, yeah. I'm just thinking aloud. I think working on fixing a fragmentation issue in a GC with a really awful heap layout anyway. At this point, we're not really going to hit those kind of pathological issues. I mean, it's going to... It could happen, but by having a larger heap, you're going to overcome it. I can always wait until such a problem does happen first. And improve the heap layout later anyway. So it's just... The thing is, if you allocate a whole bunch of tiny things and then free them and then want to allocate some bigger things, they can't use the memory that the tiny things used to be in, even though the memory is free. And different collectors get around this in different ways. Some allow a modest amount of fragmentation, like a non-moving big bag of pages collector does that. So anyway, yeah, so if I add the assertions, tidy things up a little bit, then I can merge this to master and we're done with the collector for now. I'll come back to that. Printf. So now during marking, do we need to sweep? Do we need to assert anything? If this is a valid object and is marked, we should at least assert that it's allocated and that it has a non-zero size. So I'm going to keep asserting that those bits are the way I think they are, and then we'll think of other kinds of invariants that we can enforce. So object bits heap and GC bits allocated is 0. And I don't remember which takes precedence, so it's easier just to put parens around everything. Okay, what have I done? I think there's mismatching parens somewhere. No, not there. There. Doesn't need that one. Too many arguments of function like, oh yeah, because it doesn't need a heap. So we'll come back to the sweeping code. Just going to look at more marking code. So we marked the bits, then we marked is valid object. What does is valid object do? Does that check the size? Is heap address, is bits, that should check the size there. And then we won't need it in the other code here. In the marking code here, we won't need to check cell size. So is valid object is already doing that one as well. That would be, wait, what? Is bits marked? Is bits allocated? Why would that be equal to 0? That should be failing. Is this code not running? Yeah, I bet our test is not exercising this right. Yeah, well, what we will do to make sure that we exercise the GC, at least for now, is use part 2. And, oh yeah, that's the other thing. Because we're going to drop the issue of fragmentation, we're even going to delete part 1. I'll do that in a bit. Because part 1 is a terrible test anyway. It doesn't actually test that we can trace through the heap. Right, part 2 fails. Let's see. Make, allocate lots. Good. Yeah, because that will fail, right? That should fail. Yes. Anyway, we check allocated that's checked within is valid object. So if it's a heap address and it's got the allocated bit, then full valid is those things. Yeah. And if valid, assert that cell size of pointer is not 0. Return. Yeah. Good. Now, we're going to look at the marking. We came to the same conclusion that a test is valid object. That's about all the checking we can do. Sets the mark bit there. Yeah. Alright. Assert is a heap address. So here's an assumption here. We must be at the end of the heap, but without size information we cannot check it. Can we not check it? If the current object, well, if it's beyond the wilderness pointer, we should be able to assert that cell is greater than. Now why? This should never actually happen, because we've changed that condition now. So instead of that being an if, that should be an assert. And this whole thing can go there. We'd like to assert that the object is a real object here, but the assert won't work because not all valid objects will be currently allocated here. That's right. I wanted to, maybe I'll do it separately, but I want to add a different bits here for is a valid object versus is currently allocated. Good. So we've already asserted the size, we need to just assert the allocated bits here. That's the true case there. And yeah, we could check it here. We can check it there? I think so. Yes, because whether it's marked or not, that'll still be true. Zero poison the cell, clear the allocated bit. Good. Checked that. Set the heap size. Yeah, I'd like to check that it's a power of 2, but it really doesn't matter. I don't think we're actually going to hit problems if it's not. Is a valid object. Yeah. Heap address. And that's it for those simple assertions. The rest is poisoning and other things. Poisoning, adding canaries if I want them. Oh, look, we can't check that there. Good enough. Yep. That's a Vim macro I used to remove that white space. Alright, so we're ready to make this change to add a few assertions. Good. I'm going to remove that part of the test suite that we don't need, of the test case that we don't need anymore. So remove all of part 1. 6. That's not true anymore. Part 1 can remove. Part 2. Well, it's not part 2 anymore because what is it part? Oh, it's itself. So we can actually just put the test right up in there. That should work fine. I'm going to reflow that. Huge list of numbers. Well, not huge, there's 99 of them. But they're in random order so that the tree gets built up in random order. Part 1 was ineffective and would cause issues. Test. Trust me, as programs get bigger, we'll get another test that will exercise that because something will. I'm fairly sure it's the nature of garbage collectors that something will do something in such a way that it causes a weird issue. I once had a parallel program that when you parallelized it on across 4 cores, it went more than 4 times faster. What was actually happening is that things were being allocated in a different order, and so the GC just happened to handle that in a more optimal way because there were just allocations in a different order and a different amount of working memory when executing the test in that way. So, alright, we have our tests. Let's now check for all those printfs. Put them behind some macros, except for that one. That one's behind the pzdev macro. That is not where it belongs. We want a new macro just for tracing the GC. And I'll show you what I mean, how that helps. So whenever I use printfs in any program that I'm working on at all, easy GC trace. Unless it's something just to see if execution reaches a particular point, when it's something a bit more useful, like these, I leave them in and I commit them because they are part of the program's very own debugger. Then what I do is I add a comment to each module like this. define the PZGC trace C macro to trace some operations of the collector. Make a comment like that. And add it to the build system. Here next to my other tracing code. PZ trace is a bit funny, but I actually DPZ C flags plus equals. Yeah. Yep, and when I comment that out, touch a popular include file, make and run that test again, it should give me loads of output. Well, some output. Okay. Something stupid terminal. Screen sometimes does this. I don't know what goes on. But sometimes it's easier just to open a new terminal. Oh, I also had caps lock on, that won't have helped. There we go. So, oh yeah, I wanted to uncomment that, touch a popular file. Oh yeah, then I made it, then it worked. So comment that out. Touch, make. Should be fine. Yep, good. Yeah. So therefore I get all the tracing in one place. I can enable it, and it's like having my very own debugger for purpose-built things. So you notice that Mercury actually supports this as a feature. It's really lovely. So, and hopefully Plasma will as well. It's a really smart idea to actually support that at a language level. And do more with it too. I mean, you can ask it, you can kind of interact with a good tracing system the way you can with a debugger. Some things are different, but that's the intention. It's like debugging light. You can't query as much stuff, but anyway, so that's that. tracing GC tracing code is only compiled when the GC PZ trace macro is defined. As above, and doc, because it's now documents because it's commented out, but they're for humans. Document new macro. And now we want to now do some poisoning and so on for some added security. So when we first get memory from the heap, we know that the memory coming from the operating system with this mmap call is already going to be zeroed. We know that if we do memset, we're filling that bitmap with zeros. Finally, what we want to do is when we free memory, when we allocate memory, fill it with different bit patterns so that a bad pointer really definitely looks bad. So when we sweep, we want to handle that in the sweeping code. That's a problem with those sizes. Actually, I'm going to make a couple of other changes because I noticed something else really simple that I'd like to change, and that is we say cell size, but we say object bits here. I'd rather say cell for both of them. There's kind of a nomenclature for GC things, but it's not really standardized. Rename, 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 rename. Okay, next is we want to poison the cell here. Memset, double check the arguments of memset, the pointer, the byte, and the size. We may need to make sure that we poison it before we add it to the free list. So with a single byte with a funky bit pattern, that'll do. Now actually let's do one first bit plus, oh I don't know, that'll do. So every bit set except for the highest bit. And the size. Cell size, cell. Now is cell size in bytes? I've forgotten. I think it doesn't say. Yeah. Cell size in words. Okay, so we know this is in words. We can have a comment. Good. And I think that's the only time we need that. Yep. Good. Now we can uncomment that to-do comment. Lots of small commits today. Boys cells after green. Then. And what I've forgotten is to put this behind a C macro, because it's not really required. It slows things down slightly. And we're going to want to avoid it later. So anyway, so what we do, if I'm just going to hide it behind the PZ dev macro. So that if you're a Plasma developer, somebody developing Plasma, you get that defined and you get poisoning in your builds, but the release builds aren't made with that. So, one more thing before we merge. Move a set supporting code and tracing printf's code into devs that printf's should be in a new fdevs code. Yes, we've done that. I'm going to merge that with something else later. Git add runtime pzgc. do. So now we have a working GC that can go onto the master branch just as soon as we clean up all these commits we've made. Let's take a look. Yes, plenty. So this last one with fixing up this comment. So we've got the merge commit where we started. We've removed a workaround in this test. That's fine. Fix a minor bug. Fix pointer allocation bug. Those can probably be merged because that one's so tiny. What I'm going to do, git rebase -I gc dash no. I need the GC branch to be fast forwarded to this point. Check out GC git make check out, throw those changes away, go to the GC branch, make test. Pull in those changes for the tail recursion from the master branch. That was pulling in our merge commit. So I like this -x make test. So if you do an incremental rebase, you can tell it to execute something between each rebase step, which is nice. So we remove that workaround. We can delete that because we're going to replace that anyway. In fact, I think we can do that. Fix bump pointer allocation, fix that one. Let's try that. So what it's asking me, what I'm going to do to merge these commits is just use the correct one because they're going to be squashed anyway. So the second commit will amount to nothing. Do that, and now it'll be the other half of the same change. Continue. I bet, I'm noticing that the test case pauses when we hit that allocate lots test. I bet that's in the type checker. I bet it can't handle that really big list because it creates lots of terms. I mean, it can handle it, it's just slow. So, now what have we got? What was I doing? Oh, I've done a stupid thing. Okay. Now, we've tidied up those commits a little bit. What we need to do now is squash that one. No, we already did the remove workaround in PC lots. Yeah, we can drop that change, which we'll do by merging those two together. That's fine. And some assertions. Place juicy tracing code behind a C macro. I'm going to open that. Okay. So what I'm doing here is looking for where I modified that code comment, because I kind of want to pull it out. Here, harden the GC using poisoning and add extra asserts. Oh yeah, and move the assert supporting code in the thing. Okay, that is fine where it is. This fix-up comment has to be merged with that. So, got these two which are going to squash together. I'm actually going to drop the earlier one. Add some assertions to the GC. Well, yeah, what if we did those together? Then, because those, it just makes it more coherent with the changes, with the that change to that comment. Place GC tracing code behind a C macro. Yes, that's right, and that one mixed with fix up comment. Yep. So we no longer need to remove the workaround for that part of the test, because that part is being deleted, so we just delete all of that. what have we got? This is where we're adding poisoning. And yeah, it's alright, I see what to do. It's easier just to do it than explain it, I'm sorry. So we want that change there, and that change from that line, because that's the change that we're swapping with. Yep. So it's adding the poisoning code, and just this line next to it, we've reordered the patch. Test. Add some assertions to the GC. So we're going to retitle this Harden the GC. Add some assertions and to the GC. Done. Here's the other half of that renaming. Oh, right. Duh. So I accidentally left a duplicate line in the file. And add, continue. We're nearly done here. When we're done, I'm going to get ready to say goodnight as well, because I'm going to finish up and I'm thirsty, so I'm going to go get a glass of water and I'll call it the end of the stream then. But we're now ready to land the garbage collector onto the master branch. This is working. So let's do that. Git check, git checkout GC git merge GC dev. Move our branch to the end there. Double check, make test. Double check. Yeah, cool. Sorry, I thought something went wrong with the stream, but it seems okay. It says it's okay. So, we have our branch ready to go. We can pip push GitHub. Huh? Okay. Push GitHub pull. I can click it. Branch div. So merge without fast forward the GC branch into the master branch. Now supports gub. I'll find the bug number. I'm just doing that in the browser. That is bug number 69. Alright, and make let's push that to GitHub. Oh. Oh, because I merged right folds change the other day, and I just did that through the browser. So that's fine. Let's take a look. Yeah. I'm going to delete that other branch. Oh, there's got a few things to do. Where did master go? There. Yeah, okay. So, what we do now... Sorry, I've opened GITK and you couldn't see that. I'm sorry. So, I'm going to reset to master and redo the merge. Git reset part GitHub master. Right. Now I can get... I'm going to move to git checkout DC git push origin git branch D. Because I'm going to delete that one. And yeah. Git push origin delete DC dev. Good. Okay. Git merge no and fast forward DC branch. Closes number 69 boots. Good. Let's see if that works. Well, it will work. And that's garbage collection implemented. Push origin, delete GC, and do the same for GitHub. Now there's one more thing to do. We've landed this on the master branch, it's working, we've tidied up our branches. Go back to the master branch, build this, just to make sure. And what I'm going to do, open up a new one, Cosmo website. This is the big deal. And I can't remember how the website's put together. Fox helped me move some stuff into, I think it was in data. Yeah, data roadmap 2, I believe. Basic garbage collection changes from work in progress to done. Make commit this. Update roadmap. Good. The other reason why we made sure that the main repository was on the master branch is that when we upload the website, or when I upload the website, because I've got the SSH key, it will build the documentation it finds in the main repository and upload that as well. This is good. This will have updated the roadmap on the website. There's one more thing I normally do at this point, and that's write a blog post to announce the new feature. Let's see. We have here, so language groundwork, improve module system. See, it's still marked as work in progress. If I refresh, oh, because the update process hasn't uploaded this file yet. Okay. We're done. What's that? Oh, and that update may have kicked off, may have really annoyed the stream as well, if I'm uploading information or anything like that. Oh, should have updated now. Let's see. No, still marked as work in progress. Hard refresh. Articles. It's interesting that that's not updated. Oh, maybe rsync doesn't work the way I think it does. In any case, I'll figure that out. And it's all good. Garbage collection is done. Anyway, thank you for joining the stream. I'll do more programming on a stream next Monday, I guess. And have a good evening. That's about it. Thanks.